Okay, I'm going to start off the sample proofs for Chapter 9 with some practice exercises from Section C. This is be from the Chapter 9 C2 Level 2 exercises. The first one gives us three premises. First, there exists an x such that Sx, actually I'm sorry, this is a conditional. If there exists an x such that Sx, then for all x, if px, then dx. Right? So if there exists an x such that Sx, then for all x, if px, then dx. Number 2, SB. My S is a little funny there. It kind of looks like a 5 a little bit, but that's supposed to be an S. Right? So this tells us that B has that feature, has that property, S. And then 3, PA. Right? So again, remember here, B and A are constants, and this just tells us that they have this feature, whatever it is. Right? They're puppies or they're stallions or whatever these things stand for. And then the conclusion I'm supposed to reach is that there exists an x such that dx. Okay. Now again, I'm going to do what I usually do. I'm going to focus here on this simple statement here, this simple idea dx. Right? I need to show that there exists an x such that dx. I see a d up here. Right? And the consequent of this conditional, that leads me to think that I want to be able to prove this consequent, and then maybe I can work with it to get to d. That's supported by the idea that I see, if I can get to this consequent, I see that the antecedent of this conditional is px. I see a pa down here, so I'm thinking that I can, if I instantiate this, right, since it applies to all x, I can use universal instantiation to get if PA then DA. Since I have PA, that would give me DA. And if I know that D is true of A, then I'll know that there exists an x such that DX, in this case, namely A. So what I'm going to do, I think, is I'm going to try to prove this first, the antecedent of this conditional. It looks like I'll do that based on SB, right? Remember what this stands for. This just tells me there exists an x such that S applies to x. I see right here that there is one indeed, B in particular. S applies to B. So I should be able to use existential generalization on this. Since it applies to B, I know there's at least one x such that Sx. That will let me use modus ponens on this conditional to get to the consequent. And then once I have the consequent, I can instantiate it with A. Since it applies to everything for all x, I can instantiate it to A and then use modus ponens again to get to dA. And once I do that, then I can just say use existential generalization again. Since D applies to A, there exists an x such that dx. So I'm going to show you that in action. It might make a little bit more sense if you just see it unfolding. So first thing I want to do again is I'm hoping to be able to use modus ponens on this conditional. I need to set that up by first saying from line 2, there exists an x such that Sx. That's from line 2, from existential generalization. Again, if I know that it's true of B, I know it's true of something. That's all that this says. Right? And that's what existential generalization allows us to do. Then line 5. Once I know that this is true, I can now do the modus ponens I was hoping to do. And so now I have the consequent of this conditional for all x. Right? If px, then dx. And that's just from lines 1 and 4, modus ponens. Good old familiar modus ponens. Proofs might look a little bit more complicated, but some of the ideas are still the same. In fact, we'll be using all of the rules from Chapter 8 in these proofs, just adding in, for the time being, these new rules about generalization and instantiation. And Now that I have that, I can instantiate it. Right? I want to be able to use this claim, PA. So since I know it applies to everything for all x, I know it'll apply to A as well. A is one of the things. So if PA, then DA. Right? That is from line 5, universal instantiation. If I know it's true of everything, I know it's true of this. And now, since I have PA and I have if PA then DA, then my modus ponens again, I have DA. That's from lines 3 and 6. Modus ponens. And now that we have DA, I can just generalize if it's true of A, then it's true of something. So there exists an X such that DX. And that is from line 7, existential generalization. Right? And there's the whole proof in all its glory. Hope that helps you.